Extraction of iron in blast furnace. Blast furnace is used for extracting iron from its ore. The main ore of iron is hematite ore, and the formula for hematite ore is Fe2O3. You can see in the formula that oxygen is the main impurity which need to be removed in order to get iron. Also sand, which is also, we can also call it silica, is SiO2. This is also the main impurity in the ore. Sand is mixed in the ore. So we obtain iron from whole of this in a blast furnace. You can see the blast furnace. It's a huge structure, more than 50 meters of height, and you can see hot air is coming from here, and there are different temperature zones. At the top it somehow 400 degrees centigrade, and near the bottom it's 1700 degrees centigrade. The raw materials are carbon, coke, hematite ore, and calcium carbonate. Calcium carbonate at high temperature decompose to calcium oxide and carbon dioxide. Calcium oxide is a metallic oxide, so it is basic in nature. And note that silicon oxide is non-metallic oxide, so it is acidic in nature. So calcium carbonate is used to remove silicon dioxide or sand. Let me point out the main reactions which are going on. Let me repeat first. We are putting raw materials as coke as one raw material, iron ore is second raw material, and limestone is third raw material, and we are putting it from the top. The main ore of iron is hematite, Fe2O3, and hematite ore, coke, and limestone are loaded at the top of the blast furnace, while hot air is introduced at the bottom of the furnace. You have to learn the main reactions which are going on in the furnace. First of all, the blast of hot air start the coke burning. So first reaction is combustion, in which carbon is reacting with oxygen to produce carbon dioxide. It's an exothermic reaction. Heat is produced which raises the temperature of the furnace. In the second step, carbon dioxide formed react with more carbon and produce carbon monoxide. And it's a redox reaction. And this reaction is endothermic. It takes heat from the surrounding. Carbon monoxide produced is a strong reducing agent, and if you look at the formula of hematite ore, it is Fe2O3. So carbon monoxide react with this oxygen and you get iron extracted from there. So carbon monoxide is a strong reducing agent. It reacts with Fe2O3 or iron 3 oxide to give iron. Carbon monoxide oxidized to carbon dioxide. So this is the reaction. Fe2O3 react with carbon monoxide to give you iron, molten iron, and carbon dioxide. And limestone, calcium carbonate, decompose on heating at high temperature to calcium oxide and carbon dioxide. Calcium oxide is a basic oxide, as I told you. It reacts with acetic SiO2 to give you calcium silicate. Calcium silicate is slag. It floats, you can see in the diagram, it will float on the surface and can be removed from here. While the molten iron settles at the bottom, and it also can be removed from here. So this is how iron is extracted. This iron is called pig iron because it contains some impurity. Main impurity is carbon. There is 4% carbon in the pig iron, which we are extracting through blast furnace. So in order to further refine pig iron, we put it in converter. So you can see a converter. In this converter, we take pig iron and introduce oxygen from the top, and this oxygen removes carbon. As I pointed out, there is 4% in pig iron. There is 4% carbon impurity, and we have to remove it to get more refined iron, and oxygen is introduced from the top, which react with carbon present in pig iron to form carbon dioxide. So carbon from the pig iron is removed in the form of carbon dioxide. Let me again point out, the iron from the blast furnace is impure, containing 4% carbon as main impurity. To remove the carbon, oxygen is blown on the molten iron in a large vessel known as converter. The carbon is oxidized to carbon dioxide. This reaction is exothermic, and the side effect of this exothermic reaction is this: some of the molten iron react with oxygen to form Fe2O3. So it go back to Fe2O3. Now rusting. Iron forms rust when react with water and oxygen. And here I am discussing some method to overcome this problem of rusting. The first method, important method, is galvanization. In galvanization, we coat iron or steel with a layer of zinc. You can see a thin layer of zinc, and this thin layer of zinc is even exposed over here. Zinc is gone. Now this surface is exposed. Even then, what we have observed, that this exposed surface will not rust. So let us see how it is possible. Galvanizing is a process where the iron can be protected by the coating with a layer of zinc. Zinc is more reactive than iron. It loses electrons more easily and form ions in preference to iron. Zinc corrodes while exposed iron does not rust. So zinc is more reactive than iron. It will oxidize in preference to iron. It loses electron more readily, more easily than iron. So zinc actually is corroding is, you can say, is going away, but iron remain as it is. So this coating the surface of iron with zinc is galvanization. So this is one method to overcome rusting. Sacrificial protection of iron. This is another method of to overcome rusting. Sacrificial corrosion occur when a more reactive metal is allowed to corrode instead of iron. For example, large blocks of magnesium are attached to hull of a ship. You can see a boat over here, and this is the hull where magnesium blocks are attached. And since magnesium is more reactive than iron, so it will lose electron more easily than iron. And magnesium is oxidized more easily in preference to iron. So magnesium will same way will corrode and iron remain as it is. There are other methods of to prevent rusting, like painting, like greasing, like plastic coating, and but these are the important ones.